Good morning everyone, I'm Chris and welcome back to another episode of Rift Amps. So first things first, sorry there wasn't a video last week. As I did put up on my Instagram, I did manage to finally get away for a short break, first time since before COVID, so I'm sure you'd agree, I do deserve a little bit of time off every now and again. But anyway, we're back to it, so we've got 2 weeks worth of videos for you today. So it does go on a bit, lots of repairs, lots of bits and pieces going on, but the first thing I'm looking at is a hi-fi amplifier. So this is a Pioneer SA510. It's kind of one of these classic 70s, 80s solid state hi-fi units that you used to see in every living room, front room around the country. They sound fantastic and they're extremely robust and reliable. So it's actually quite rare to have one come in to be looked at. Now this one unfortunately has lost output on the left channel. I think it's the left channel. Yeah, the left channel. It hasn't lost output fully, it's just very, very weak. Now the common issue is the speaker select switch. So it's got 2 sets of speaker outputs, A and B, and then you can select between the 2 or mute the thing entirely. And it's quite common for this switch unit here just to get full of dirt and grime and stuff and need cleaning out. But we've done that and it's still playing up, and I've done tests and measured continuity through, and the signal is still weak on the preamp itself, so way before the switch. So we've got to do some further investigation. Thankfully on these I haven't got to remove a lot to get to it. I had to take the top cover off, and you can take the bottom cover off to get to the underside of the PCB, and you can just work on it like this. So it's really, really handy. So I've just been going through it. I found the service manual online, which is good news. You can tell there's lots of dust and stuff in here, which is not uncommon to see. So I've just got to go through, got to do some signal tracing, work out exactly where that signal is dropping off. I have a few suspicions already as to what the issue could be, but I still need to confirm that. But I'm not going to walk you through the full repair on this. It's unlike valve stuff, hi-fi stuff is quite boring, a little bit laborious, just not that exciting. So unless you're really, really into it, then there's no point really showing it. But once it's up and working and fixed, I'll show you. But the right channel sounds great, sounds fantastic, good full volume, good tonal range, sounds great. But the left channel is just really, really quiet. So I was hoping it was just the switch that needed cleaning, but no, there's a further issue. So we need to get that diagnosed. Vox AC30 is done. Well, almost. It has had full service electrolytic recap. There's one electrolytic, that Hunt's up there, that's still tested well in spec, no leakage at all. So that's the only one I've left in. The rest were done. Couple of resistors and things that needed swapping out. Rotated the speakers and rewired those, and we are all good to go. We had an issue with the tremolo not tremoloing. The oscillator wouldn't bump start. I had tested the foot switch, but it was working. But once I had put it all back together, it stopped working, which is no good. So I've had the egg apart. That's the foot switch itself, SPST, low profile, and even though it clicks nicely, we can test it with a meter. Probably about once in every 20 presses does it actually make connections. So got a new one on order. That's easy enough to fix and put back together. Wire that, we'll make the connection back up, wire it back in, and then this thing's good to go. So it sounds incredible. It's an absolutely brilliant amp. And yeah, just a yearly check over from now on for this customer. Just keep it going. But one very, very nice early 1964 JMI copper top Vox AC30. So just had this one dropped off at the shop. It is a Laney Pro Tube 30 watt. You don't see these very often. 80s, I think. He's just bought this amplifier, or took it in trade, and has asked for me to give it a full recap of all the electrolytics. So nice easy job. He said there's nothing majorly wrong with it, just needs a good service and recap. So that's what we're going to do. It's got a couple of push-pull things going on and whatnot. Looks like it's been kept somewhere damp, because these are all rusty, but this side not so much. So I don't know what's going on there, but here's the rear. Looks like it's got a set of 6 V6s. Really cool amplifier. So, not much to do. Let's get the chassis out and have a look inside. Let's have a look then. So, it's typical British 1980s amplifier build quality, which is generally very good. Got an electrolytic cap here, filter cap, LCR. Pair of 6 V6s and 4 preamp tubes. That'll be the phase inverter, which is a AC30. And we'll go through the rest of it. Quite small transformers, which is interesting. But it's meant to be 30 watts. So how they're getting 30 out of a pair of 6 V6s, I don't know. So we'll have to measure it on the bench and see what is what. But let's get this flipped over and have a look inside. So as I said, typical 80s British build quality. So we've got PCB design, all the traces on the underside, which is a nightmare to work on. 1987, that transformer. This has got a pat test sticker with 1988 on the back. So, yeah, very interesting. So, customer wants can cap replaced and then all of these electrolytics done, and then just give the thing a good service. So that's really cool, really interesting. I've been thinking, I can't remember ever actually having one of these in the workshop. So this might be a new one to me. I've managed to find online the schematic. It looks very martially on first inspection, but we'll go through it and see what's what. Okay, I need to get some parts orders. Just working on the Laney, about to say PV then, and in order to do the electrolytic recap, you've got to pull all the pots off the front, disconnect some wires, and that way you can fold the board all the way down to get to the solder pads on the underside, because unfortunately you can't get to them on the top. Absolute faff. Good and bad news then. So the new foot switch has arrived, all installed, all wired in. Managed to reuse the original nuts, keep it looking original. Tremolo now works. That side of the amplifier is sorted. Unfortunately, the greenback has got some awful cone rub and distortion. You can tell the speaker's just starting to crap out. So, you know, he said he replaced the speakers late 70s. So, you know, 30, 40 years of use is pretty good. But unfortunately, it does need replacing. So we've looked at options. The romantic in me wants to put back in a set of blues, reissue blues, return the amplifier to its original tone. But we've just looked at prices, and they are, it's going to cost him 450, 460 quid to to do that. Anico's got so expensive lately. So he's decided just to replace one speaker, just the broken one, with a reissue greenback, which will be absolutely fine for this. It'll work great. That's going to cost him, just 120 quid or so. And then he can think about, doing something later on down the line. So yeah, so we're not going to get this one out the door today, which is a shame. But customer completely understands. He'd rather get the amp sorted rather than bring it back. All I've got to do now is just glue the base of the foot switch back on, swap the speaker out when that arrives next week, and then this one, hopefully, we can finally say it's done. Sometimes you've got to fix your own test equipment. This is one of my many valve testers, just a simple one. Works really well, easy to use, but it's been, well, I haven't actually serviced it before, so it's about time. So there's not a lot of capacitors, it's mainly resistors and things inside, but this 1 meg resistor measures 2 meg, so that's got to come out. Going to test that cap. Got a big old high wattage resistor there that we want to check, and one here as well. So just going to go through those, check those out. It's not that important, but I do need to get it done. I've been putting this off for a while. So yeah, it's the inside of a very simple valve tester. It's quite a good one actually. But yeah, let's go. Okay, so eagle-eyed of you will notice that the resistor I was talking about was in fact a 1.5 meg, not a 1 meg. It still measures 2 meg, so it's well over. So I've now got the correct value in there. Cap test okay. There was a 470 ohm 5 watt resistor, which if we look on the schematic is there. And it was paralleled with a 680 ohm. Not sure why. The only reason I can think of was that this resistor had drifted high in the past, and rather than replace it, they just tacked another one off to bring the value back down. So I've now got the correct 470 in, and the only other one that's left is this 2K resistor between the power and the test switch. There. The one in the amp is a 1K8, but it actually measures close to 2K. So we'll leave that. We'll leave that in there. And that should be us ready to go. Let's give it a test. So just testing a 5-way 3. Done the shorts test already, but if I advance the sensitivity control up to 40, which is what the book says, 40, we should get a reading on the dial. There you go. She's working again. Good news. 6G3 progress. So I've done the preamp wiring, all on this side. I've done the pot wiring, all up on this side. All I've got to do now is heaters, mains transformer wiring, then the input sockets for this channel, and then I'm going to use shielded wiring over that way. So yeah, this one's coming along really nicely. Quite happy with it. It's come out a lot neater than I thought it would actually. So I'm quite happy with the layout I've done. For those that don't know, it's a standard 6G3 Deluxe, but I've put the filter caps on the main board rather than on underneath the doghouse. So I've had to make some changes to layout and things like that. So yeah, that's really nice. Quite happy with that. Anyway, we've just had this Dr. Z turn up. This is a Jazz 2040, which is a 4 6v6 output valve amplifier. Customer contacted me saying it's he opened it up because he could smell some burning and there's some issues with it. He sent me some pictures, but I'm going to remove the chassis to show you, and then you can see exactly what it's coming for. So we're going to give it a service as required, and he supplied his own set of 6v6s that we can then check the bias on, and soak test. As always, with Dr. Z stuff, you get massive transformers with your purchase, which is generally always a good thing unless you're going for a very particular sound. One thing I have noticed is on the valve chart, the AT7, which I assume is the reverb driver, someone's put 12AU7 instead of 12AT7, so we need to investigate that, see which is correct and what it needs. But we come back to look at the amplifier, 4 6v6s, got some heat marks there, interesting. And let's spin it over. Okay, so typical Dr. Z construction, which is a large piece of FR4 using turrets to mount all the components. I never quite understand his layouts and the way he organises things, but it does work, and he does make some very interesting sounding amplifiers. So let's have a look. What can we see? So we've got our 4 6v6s, and I can see 1K2 grid stoppers and 470 ohm screen stoppers. They look okay. And here are the cathode bias resistors for the output valves. Now, I'm sure we can quickly work it out. Yes, so you've got 2 output valves sharing 1 resistor and the other 2 sharing this one. And as you can see, at some point in the past, that's got nice and hot. It's burnt the board. Now, the customer did contact Dr. Z and asked the question, and he was advised that the value of these, which is currently 180 ohms, needs to be increased, which will cool the bias, to 250 ohms, which, to be fair, is kind of a standard value for a pair of 6v6s. Now, the E12 value, which is the modern value, is actually 270 ohms, which is what I'm probably going to fit. But if these have got hot, we need to test these caps too, swap them out as required, and check anything else in the B+ rail. Make sure all is good. So once we've swapped those resistors out and done our tests, we can install his new set of output valves, check the bias, make sure we're happy with how it's running, and then put it all back together. Okay, resistors replaced, new bypass caps in as well. I fired it up, I've taken the measurements, and we are still far too hot. So, as you remember, each cathode resistor is shared by 2 valves. So, got valves 9 and 10 sharing one, and 7 and 8 sharing the others. Here's the measurements. That's the actual resistance of the cathode resistor, voltage drop across it, anode to cathode voltage, puts us at 120% each on one side and 122% of max of the other. So 270 ohms is still too low, so we need to go up to the next value, which is 330 ohms, and that should bring us close enough where we'll be good. But I dread to think what this was running at with the original 180 ohm resistors. Yeah, who knows? We've got almost double those, well, over double those. No, almost double the value of the original resistors to get the bias on this amp back to down to something reasonable, because look, clearly it was far too hot. Right, going to swap these out and take it from there. Right, so 330 ohms installed on each channel. We've got it running on the bench, but I'll just talk you through the bias figures. So these are the old ones when we had the 270s installed. Remember, we were running at 120 and 122% on each side. Now we've got the 330s in. We've ended up 109 and 108.5% each side. So much cooler, much closer. And bear in mind, that's not the full plate dissipation or anode dissipation. That includes the screen grid as well. So we're close enough to 100% that I'm happy. One thing I had to calculate was the dissipation of the bias resistors themselves, each of them is dissipating 2.36 and 2.33 watts. So I've been able to use 5 watt resistors because we always at least double rate them. So I haven't had to go to 10 watt resistors as I had before. That's overkill, that's too much. The 5 watts are fine, and I proved that with the calculations. So anyway, it's now running on the bench and it's running fine. There's the sine wave. And this one's got a mid control, so just adjusting the mid control does do weird things. So I've got it set about halfway. Injecting 150 millivolt 1 kilohertz sine wave as always, driving in our 8 ohm load, and we're currently putting out 13.6 volts RMS, and I can get that up to, before it really starts to square, of about 14 volts. Now 14 volts RMS into 8 ohms is 24.5 watts, and this thing should be 40 watts. So to get 40 watts, we need, well, 14.5 watts is 18 volts RMS. 17.5 volts will be 38.3. So we're looking 17.8, I suppose, is where we want to get. And can I get that clean? No. If I mess around with the treble control, we can get, if I crank the treble control, see, I just can't get it close to 40 watts. So I don't know how they measured this thing, but I can't get 40 watts out of it. But it's a very nice sine wave. So we'll set it there, and then it's got the half pound switch. This drops it down to 7.2 volts, which puts us into 8 ohms, about 7 watts. So it does seem to be slightly down on power, doesn't it? And it can't be to do with the biasing, because now I've got the valves running really as close to their maximum as possible. So it's an interesting one. I haven't done anything stupid with the controls, have I? No. So we've got some more investigation to do. I'm going to go through and take some more voltage measurements, check that it's okay, and check where it needs to be. Check it's got all the right valves in the right place, because that could be, on the preamp side, that could be an issue. And see where we end up. Yeah, I messed up. I had the wrong preamp valve in the wrong position. It's doing a good 40 watts now, and I'll just give you, just running a loop through it. We'll just let that run into the load for a bit, just burn in, make sure we're happy with everything. And then I can box it up and get it back to the customer. So that's all good news. Dr. Z, Jazz 4020, or whatever it's called. Job done. Okay, final update on the AC30. The new greenback has been installed. I had to, with the customer's permission, just slightly notch out the bottom cleat here, because this speaker, for some reason, is, you know, a 1/32 of an inch, slightly larger than the old one. So I've had to just with a file take that back. Customer approved it, said it was okay, all wired in, all plays fine. This amp is now done. So I've really enjoyed this, actually. You know, as I said before, I don't get many AC30s in the shop. So to have one come in that's, you know, quite a cool one, it's got history to it, it sounds great, it sounds absolutely brilliant. So I'm happy with it. Trem works, it's putting out full voltage, the tone is unreal, sounds brilliant. Would love to hear it with a set of blues, but this is what we've got. So yeah, all good to go. Customer can come and collect it. Well, that's it then, guys. Thank you very much for watching once again. The sun is out, the rain has disappeared, which is nice. So I'm enjoying the last couple of days in September. and then we are fast approaching Christmas. So if you need any repairs doing or anything like that, please get in touch, because I am busy. I've got a lot of work on. So if you need something before Christmas, now's the time to get in touch. Anyway, I shall see you all at the next one.